already started sets, right? Okay, I say that sets will be indicated by capital letters, correct? And we list the elements, let's say like that, in curly brackets, correct? Okay, there are three ways to describe to you a set. First is by writing out the description, okay? Second is by listing out. And third one is by the set notation, whereby we use X is such that X is given that I will describe to you. Remember this? Okay, now then, never mind, I'll fix it up. Don't have to bother about it. Then I also have these elements here. If it is an element, we use this symbol, right? This one is what? Not an element of. Correct? Not an element of. Now, then we also have two sets are equal when they are exactly the same. They must have the same number of elements and they must also have the same type of elements. Correct? Cannot be one is 1, 2, 3, the other one is A, B, C. It's not correct. The element must be exactly the same. Okay? Alright, then we move on to empty sets. Empty sets is given by the symbol either curly bracket with nothing inside or like that. Remember? This is called empty set or null set. It means the same thing. It means there's nothing in that set. Okay? Alright. Then after that, I gave you exercise 1A. Alright now? To try all the questions there. Can I go through that later? I go to the one that I've gone through in the next section first, the Venn diagram and so on. Now, this one is called what? What is this? Universal set, right? Universal set bounds the context of the question. Okay? Then I talk about a set A. Alright? Those elements inside set A will be those elements that belong to the set A. How about this symbol here? What does it mean? A prime or A complement. What does A complement mean? Not inside A, but it's still in the universal set. Is that clear to everyone here? Yeah? Okay, so we have A complement. Then also, we have subsets. Remember, subsets is like that. Then what is the difference between these two? This one is a subset, this one is a proper subset. Now, to qualify as a proper subset, there must be at least one extra element outside. Remember I told you before? Okay? If not, it's just called a subset. Understand what I'm saying? Okay? Alright, good. So, let me finish this thing up first. Alright. Can we all look at page 8? Okay? Universal set, complement of a set. I've already done it with you yesterday. Right? Okay. Now, I'm going on to work example 3 first before I go through exercise 1. Will that be okay? Right. So let's take a look at example 3. That I'm going to explain to you the line that I've given you. Remember yesterday I gave you the null set and the set itself is a subset of the set given. Okay? Alright. So what do we mean by that? Okay. Now let's look at example 3. It is given that the universal set is X such that X is an integer between 1 and 10 inclusive. Okay? A is such that X is a perfect square. Okay? Now, they want us to list part 1. List all the elements in the universal set and of A in set notation. Okay. Let's list the universal set first. It's an integer between 1 and 10 inclusive. So it must be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Agree, class? That means our whole question is from 1 to 10 only. Because it's a universal set. Okay, now let's take a look at A. A is a perfect square. That means from this universal set, what are the perfect squares? Okay, perfect square will be what? 1, right? 1 square is 1. Some more? 4, right? 2 square is 4. What else? 9. Correct? 3 square is 9. Any more? No. Okay? These are the perfect squares. 1, 4, and 9. Are you all okay? Can you understand? What are perfect squares? 1, 4, 9, 16, 25, right? They are also 4 square numbers. Okay? What is the perfect cube? 1 cube is what? 1. What's 2 cubes? 8. What's 3 cubes? 27. These are called perfect cubes. Understand what I'm talking about here? Okay? Alright, now then let's take a look at part 2. What do they say? Draw a Venn diagram to represent the sets universal and A. Okay, I'm supposed to draw a Venn diagram to indicate this. Now all of you look up. This is universal set. This is set A. Alright? Usually I will put the elements that's in A first. 1, 4, 9. Okay? Now then what else is that? 2, 3, 5, 6, 7, 8, and 10, right? Alright now. This will be the Venn diagram that represents the set universal and A. Do you understand here? Now, students will always ask me, Cher, can I put comma here? Okay, actually it's not advisable to put comma. Okay, but the thing is that what I'm worried is that some people will write like that. 2, 3, 5, 6, 7, 8, 10 like that. Cannot. Can you please write it properly? Understand? Separating with things there. And then this is 1, 4, and 9. Don't go and put 1, 4, 9. Do you know what I'm talking about here? So separate it up. Okay, but don't jumble the place. Let me go and do hide and seek for the numbers. That's very bad too. Okay, class? Can? Alright, now then, because you know why I say better don't put commas. Some teachers are so particular that they don't want to put commas. I'm okay with commas because you want to separate the elements. Because the teacher tell me that the comma is actually an element of the set. I say, what rubbish? The student is just distinguishing the numbers. That's all. But you see, they can be so particular that I don't know how to correct them. Understand? Okay? So there's nothing I can do. I can only advise you. Okay, I will not do that because I find it so natural to put the comma. Do you understand what I'm saying here? Okay, Alright, now next. Part 3. From the Venn diagram, list all the elements in A complement in set notation. What do you mean by A complement, class? Those that are not in A. Even if I don't draw the Venn diagram, I can list the complement. Agree. So what's in the complement? Tell me. 2, 3, 5, 6, 7, 8, and 10. That's all. You don't even need the Venn diagram to list the complement. Okay, just look at the sets you do. Okay, but I need to warn you. If they describe like that, quite difficult. You list down easier. You can see. Do you understand? Okay? Alright, now next part. What did they say? Describe the set A complement in words. Okay, let's look at the answer. Part 4. A complement is the set of all integers between 1 and 10 inclusive which are not perfect squares. Isn't it? Correct? If this is perfect square, this is not inside. Of course, this one is not perfect square. Correct now? Yes or no? Okay, next part. State the values of number in universal, number in A, and number in B. Now, do you agree that number of elements in universal is 10? What is the number in A? How many elements? You cannot count up. 3. Yeah. What's the number in A complement? 7. Of course must add up. You understand? Because if not here, then of course must add up. Correct, class? How come I can add students from 401 all the way to 409 and tell me the total number of students in the Sec 4 level? Because there's no intersection. It cannot belong to 401 and 402 together. You understand? That's why I can add it up. You understand? If there's an intersection, then we have to be careful. That means, for example, there are some intersection. That means there's coincide. Okay? Then I will tell you about that later. Alright? Now, so last part is number of A plus number of A complement equals to number in universal set. The answer is yes. Since A and A complement contain all the elements of the universal set and do not contain the same elements, we have this. Correct? Yes or no, class? Yes, so this is common sense. Okay. Now, next we go on to proper subsets, like what I've explained yesterday. On page 10. Consider the sets A, 1, 2, 3, 4, 5, and B, 1, 2, 3. How can we draw a Venn diagram to represent the sets A and B? Since I want no talking, hello? Since all the elements in the set are distinct, we cannot write the same element twice or more. We can draw a Venn diagram as shown below. Now, I've shown you this yesterday before, right? Correct now? Okay, now, we say that B is completely inside A. That is, every element of B is an element of A, and B is not equal to A. We say that B is a proper subset of A, and we write B proper subset of A. Now, there's a difference, yesterday I already told you. If I write B proper subset of A, that means I have A here, B here, there must be at least one element outside. You can have more, it doesn't matter, but must have at least one. But if I write like that, it can be like this, correct? Or there can be nothing here, all inside here. Now that means actually A and B are equal. Can you see it now? Because there's nothing outside. So this is called subset. Understand? Proper must have at least one extra outside, at least one. Okay, so this is called proper. Okay, now we go on to example 4. Let's look at example 4 on page 11. All of you at page 11. Okay, what does page 11 say? It is given that X is a set of all letters, okay, in the word Singapore, and Y is a set of letters in the word Kings. Draw a Venn diagram to represent the set X and Y. Okay, that means this X has got what? S, I, N, G, T, O, R, E, right? Singapore. I belong to Singapore. Oh my God. Singapore citizen. Singapore citizens. So why? Because I write the comma and forget. Is it correct already? Okay. What about Y? Hints. Okay. Draw a Venn diagram to represent the sets X and Y. Okay, you must look up. If it's a subset, you must draw inside. You cannot draw outside. Understand? Okay. Now, P, is it in? Yes. I, is it in? N, in, S, in. So, I must have this. X is the bigger set, right? Correct. Y is the smaller set. Y has P, I, N, S. Correct? So, what do I have here? G, A, P, O, R, E. Correct now? I make a mistake. What did I make a mistake? Can you see this one is double? You don't have double. Any double again? Talking to you. S, I, N, A, P, O, R, E. Correct now? Oh, you want to sing A? Nonsense. Then you write like that. Write it downstairs. This class is terrible. So confirm no gay already, Everybody okay? Okay? What no gay? No gay in Singapore. Oh my God. I didn't say anything. I'm just talking about elements. Okay? Alright, so it's a subset. Okay? A subset must be entirely inside. Everybody clear? Okay, so this is your example 4 Venn diagram. Now, then they ask you, is Y a subset of X? Yes, Y is a subset of X. Because every element in Y is an element in X. But look at the sign carefully. What did they say? They just say they don't have sign. It's just a subset. Of course, it's a subset, right? But can I ask a question? Is Y a proper subset of X? Yes. Now, how would you write? This one I want you to write down. Y is a proper subset X as every element of Y is an element of X, and number of elements of Y is less than number of elements in X. This is how you explain that it's a subset. Can you write this down? Okay, this is how you describe the subset. Is that clear? Not only subset, it's the proper subset. Understand? Yes or no? Okay, alright. Now, next. Can we look at page 12? Remember yesterday I asked you to write the null set and the set itself are subsets of the set. Okay, what do I mean by that? Now, supposing I have a set A which consists of 1 and 2. What are the subsets of it? Now, all of you look up here please. The subsets. Okay. There are actually 4 subsets here. Okay, now, how come? Now, null set is always a subset because nothing much sure is a subset. Understand? And the set itself is a subset. What other subset do I have? Just one also can, right? Alright, what else? Just 2, right? Okay, now let me just tell you this first. Can you see that these 2 are proper subsets? This one is not a proper subset. Alright, because it's an equivalent actually. Can you see? Okay, now let's take a look at page 12. Consider the set 1 and 2. What are all the proper subsets of S? Firstly, it is obvious that 1 and 2 are proper subsets of S. Okay? And in figure 1.4c, we observe that we can draw the empty set completely inside S. Thus, the empty set is also a proper subset of S. Therefore, all the proper subset of S is 1, 2. Sorry, the 1, 2 is not included. Oh, sorry. All the proper subsets of S, 1, 2 are the null 1 and 2. So, this and this are proper subset. This one is not a proper subset. Do you understand what I'm talking about here? Okay, because this is an equivalent set actually. So this is just called a subset. Do you follow? A subset, not proper. Okay. Actually, how do I know that there are 4? I can teach you a trick. How many elements here? So it's actually 2 to the power of 2. Power 2. 2 elements. Okay, I'll show you another one. What if I have 3 elements? No. If I have 3 elements, there will be how many? Let's say I have this, I have A, B, C. Let us this down. Okay. First of all, I have the null set, right? Then I will have the set itself. Alright now. What are the possible subsets again? Single set, okay? Then A, B, B, C, A, C. Any more? Any more? All possible one listed? Yes. So how many? 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 3, because there are 3 elements. 2 to the power of 3, that means there are 8 subsets. All of the 8 subsets, all are proper except this one. Do you understand? It's always the number of subsets, right? All are proper except the one that means you minus 1. Understand? Because that one is the set itself. Okay, then I want to ask, what if there are 4 elements? How many subsets? 2 to the power of what? To the power of 4. What if I have this one? I have A, B, C, I have n elements. Okay, it's not 1. Because this one is A, B, C. 1, 2, 3, all the way until n. Number of subsets will be 2 to the power of n. Depend on how many elements here. It's not binomial lah. It's 2 to the power of something only lah. Where got factorial? Don't have factorial ma. Okay? This is not a general term. Then you go and tell your assistant you put full stop there, you say dot dot dot. Then you tell them it's go on forever. Okay, then you put a A, right, put a dot on top, A, recurring. Okay, you see whether the system will understand you or not. Okay, alright. So the number of subsets let's say the thing got n elements. The number of subsets will be to the power of n. Understand? Can or cannot? Can or cannot? Okay. How come got 16 if there are 4? I want to show you how come got 16. You got to this until crazy but don't worry exam I don't think we are so cruel as to give you this type of question it's a waste of time, correct? It's a complete waste of time and energy. To me, if I see this kind of this I straight away won't do it. I do the rest first, then come and talk about it. You get what I'm talking about here? Yes or no class? Okay, that's why I say an empty set is a subset of itself. So now the set is a set of itself. Then all the others are proper subset. Plus the empty set. Understand? The set itself is not the proper subset. That's all. Everybody clear? Everybody clear? Okay, good. Now, so I've completed all this. Alright? Let's move back to exercise 1. Okay. Alright, let's move back to exercise 1A. I want to go through it because after that I will give you the 1B to try. And also I want to do some things on the foolscap paper already. Okay. From page 7, all of you turn to page 7. I've done question 1 for you already, right? So there's no need to go through, correct? Now let's look at question 2. List all the elements in each of the following sets in set notation. X is a positive integer between 1 and 10. Now when they don't say inclusive, 1 and 10 is not excluded. It's not included. Do you understand? So, are you able to list this? 2 all the way to what? 9. Okay, good. Everybody okay? Did you put into curly brackets? Yes, okay, good. Part B. Negative integer between negative 10 and negative 1 inclusive. So it's negative 10, negative 9, negative 8 all the way until negative 1. Everybody okay here? Okay, Now you'll be surprised O level sometimes one part of it is just that simple. You just list and they give you 1 mark. Yes, really, really. And then some people don't know how to list also. Because they see already. For example, O level there's one question sometimes. Evaluate what's this value. What's the answer? 1, right? 5 degrees. I put it to negative 5 degrees Celsius. And then you please do that. Can you do it? What? This is one, a lot of people will go and put 5, you know. You know why? Do until gila already. Understand? What about 0 was 5? You know? There's some people when I give this equation of line, what's the gradient of x? 0.
Yes.
What's the gradient? 1, not 0. 0 your head, I give you 0, I tell you.
0 straight
Do
line.
you understand? Okay. Next part, C. X is a positive even integer such that it's like that. So you must start from 0, right? 0, 2, 4, 6. All the way until positive. My goodness, my mistake. If it's positive, it must start from what? Okay, correct now. My mistake. So 2 all the way to 12. Agree? 2, 4, 6, 8. All this, Okay, now next one. Part D. D is a set of vowels in the word happy. So G is what? Just A, like that. Understand? Elements must put in terms of curly brackets. Clear? Okay, so question 2 is fine. Is everyone okay here? Is everyone okay? Alright, good. Number 3. And you stop talking now, then. Okay. List all the elements in each of the following sets in set notation and state whether it is an empty set. E is the set of odd numbers that are divisible by 2. This is confirmed an empty set. Because there's no odd number that's divisible by 2. Okay, now B. X is a month of the year with more than 31 days. This is confirmed another empty set. The maximum is 31 days. Maybe a month with 32 days. Don't have Understand? So this is another empty set. Next, x, such that x is an even prime number. Is there anything in this set? What is it? 2. Even prime number, there's a 2. Don't tell me it's empty set, it's not 2. Understand? So there's an element of 2 down there. Okay, so everybody okay with question 3? Yeah, no, these are just the basics. Because sometimes they describe until you don't know what they're talking about, so it's very difficult. Okay, now I know you're tired. This is too basic for you, I know. Don't worry, you don't know the basic, you don't know the future. Understand? Because later on I'm going to more difficult questions. Alright, next one. Question 4. D is the set of days in a week. So you will have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Am I right? How many elements there? 7, okay? Alright, good. Using the notation, element or not an element, describe whether each of the following is an element of or is not an element of D. Tuesday, of course, is an element now. Sunday, of course, is an element now. How about March? Of course not. How about holiday? No lah. Do you understand? If you see, if you look like that, think of like English like that. Okay, let me just tell you how. Okay. Oh, this is very easy. Okay. Look here. You cannot think like. Let us spell properly. Monday. Monday, Tuesday, Wednesday. What if you don't know the spelling? I also don't understand why you don't know her. Okay lah, if you write short form, I will accept it lah. But this kind will never come out one, no? This appetizer only lah. Think I so kind man give this kind of question. Monday, Tuesday, Wednesday, okay? Now, first question. Tuesday. Did you see the word Tuesday here? Yes. So, Tuesday is an element of D lah, like that now. Next, Sunday is an element of D lah. Okay? Then you look at March. Do you see any March down here? The spelling you know. It's not you think of the calendar, no. Okay, so this is not an element of D lah. Then walao eh, how can you say this? It's holiday inside here.
Yeah. It's a holiday, it's a day.
No,
it's a day.
It's not like that, say. It's the element itself. You cannot like that. So holiday is not an element of D. Understand? Because it's nothing here, nothing here. Understand now? Okay, so that's it. Okay, don't argue with me. Argue with me when you go and find out. It's up to you one. Then you get wrong. That's it. Done. Okay, so holiday is not an element of D. Alright? Next, number 5. P is a set of all perfect squares bigger than 1 and less than 50. Perfect square, is 10 an element of P? 10 is not an element of P because 10 is not a perfect square. Okay, next. List all the elements of P in set notation. Now I'm not going to list all. Okay, bigger than 1. So you start from what? 4. All the way until 40. 42, man? 49, Am I right? Where got 42? Right? 4, then what? 9, then what? 16, then what? 25, then 26, then 49. Oh, you do that well, too very clever, right? Any number also go back square, Okay, now next, number 6. List all the elements in each of the following sets in set notation. Okay, very simple. Color of the rainbow. ROYGBIV. Red, orange, yellow, green, blue, indigo, violet. Sorry, that's why I say it's just for the information. This kind of thing will not. Because people write there, I never take physics. I take bio. Okay, alright. Next, X is. So I also don't need you to this. X is a public holiday in Singapore. You can have what? Christmas lah, Chinese New Year lah, Labor Day lah, alright, so not important. Now next, K is a set of consonants in the word symmetry. Consonants means the non-vowels. Okay, so it's just music, alright? And you can only list it one time. Do you understand? List it one time. So the answer should be, let me just take a look. Question 7. problem meh? But this class jialat already, hor. Holiday is okay. Everything will talk bubble. Don't know what you want. Okay, next. X is a teacher teaching my current class. Of course,
Monsieur.
Zero.
Okay, that's it done. Okay, no need to list. Okay? Alright now. Next. Define each of the following in words. Let's look at N. Now of course, it's quite difficult, right? What does N represent? Even numbers, right? Okay, even numbers, you can say even integers from 0 to, no, even integers starting from 0 because it's all the way. Can you see it's all the way? You can see it now. So it's up to you to describe. As long as you make sense, I will give it to you. So it's an even integer. Now next one, what about this one? N. It's a non-negative even integer, right? Can you see it's a non-negative? From 0 to what? 8. Non-negative what? 0 is non-negative what? When I say non-negative, it can be neutral, no? Correct, no? Non-negative can be neutral or positive. Right? Say that. Okay? Alright, so never mind. This one is up to you to describe. Okay? So what is so called? Okay. I want to know about O, the set O. What do we have? Perfect cube, right? Perfect cube, agree? Okay, how about T? Divisible by 5. Integers that are divisible by 5. Do you agree? Yes or no? Okay, also can? Doesn't matter? Okay. Now next, 8. It is given that X is a perfect square between 10 and 15. R is a positive integer less than 5 that is both a perfect square and a perfect cube. These are the elements, so on and so forth. Is question 8 okay? Are you all okay with question 8? Then I don't have to go through this. Okay, alright. Now, question 8 is fine. Now, it's question 9 and 11 that I want to go through. Because this 2 is a bit difficult. Because some people, they are not sure of the set notation yet. How many of you need to go through number 8? Are you okay with number 8? Yes, okay, good. So let's look at number 9. Okay, let's get number 9 now. State whether each of the following statement is true or false. If it's false, explain why. Now, can you see that C is an element of? So when they say not an element, this is false, right? Alright. Okay, that's the first one. Next one, part 2. That's why they want to confuse you. This is an element of CAR. This is false. Okay. What are elements of this? C, A, and R. You can say C is an element, A is an element, R is an element, not CAR. There's no car. Unless you have a set car, lorry, bus, then car is an element. Do you understand here? Do you understand? Okay, alright, good. Next. Now, this one is even worse. Do you agree this is a set? A set is not an element of another set. It can only be a subset. Do you understand what I'm talking about? Okay, this is talking about this whole thing. Do you see this? Now, that's another story. All of you look up here. If I have this, all of you look up. What does this mean if I have this set? This set consists of the null set, the set A, the set B, and the set C. So if I say C is a set of this, is an element of this one, is this correct? That is correct. Do you understand what I'm saying? It's a different story here. Okay, Alright, good. Last part. CAR is equals to 3. This is not absolute nonsense. They are not equal. Can you see? Okay, what can we say? Number of elements in CAR is 3, right? This one is correct, right? Correct. So the answer should be false, 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 false. Everything is false. false. Okay? Now, next, question 11. State whether each of the following statements is true or false. If it's false, explain why. Okay, this is interesting because I chose all this because it depends whether your basic is right. Okay, let's take a look at the first one. What does this indicate? Now set, that means there's nothing in the set, right? This set has got 1 in the set. 0. So are they equal? No, they are not equal, so it's false. Okay. Next one. This one is just confirm correct. Null set equal to null set. Okay, so this is true. Okay. Now, next. Now, this set consists of the null set. Actually, set has got 1 element. So is this an empty set? No, so it's false. Okay? Now, next. What does this mean? Number of elements in a null set is 0, is it correct? Yes. Because they are nothing. There's number is 0. Correct. Now, it's different from here. If I have a set that is like that, what is the number of elements in A? 1. There's one thing down there, it's called 0. Do you understand what I'm talking about? So that makes a difference. Okay? Now, I'm still worried about question 8 in case you don't know what we're talking about. Can I just go through that to complete it? Okay? Now, it is given that Q is a perfect square between 10 and 15. Okay, what is the perfect square between 10 and 15? 10 and 15 have or not? Don't have, okay, so it's the null set, right? R is a positive integer less than 5 that is both a perfect square and a perfect cube. Yes, it's 1, right? Everybody okay? Question 8 is null set and 1, right? Okay, now next one. Are Q and R empty sets? Which one is an empty set? Q. R is not an empty set because R has 1 element. And that is 1. Is that clear? Is that clear? Okay, so I've completed all these of you. These are basic. Are you all okay? Can you understand? Okay, good. Next. I've also done the Venn diagrams, complement, and so on. Okay? Alright, now, I'm going to give 2 sets of work. One set is in the notebook, one set is on the full scan. I will start the full scan with you. The notebook one you go home and do tomorrow we go through. Yes? Yeah. Okay, of course, your content page is number 1 now. Alright now, the Emacs content page is number 1. In 12. Just write sets will do. Now, start on the full sketch paper. Okay? I'm going to give 2 sets of work. Tomorrow I will start all the shading intersection. Okay? Now I want all these to be done in a notebook. This to be done on the full sketch paper, 246. I will start question 2 on the full sketch now. Okay, let us look at question number 2. Render data. It is given that universal set, all of you must practice how to write. Universal just write like that. even number. Write down first, like that. List all the elements in universal and of B in set notation. Okay, what do you think is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Weird. Okay, some lazy bums will ask me, can I put 1, 2, then dot, 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 cannot. Because the set element is not dot, dot, dot. Do you understand? They must list. Okay, B. As I say, the question will be bounded by the universal set. So, since x is an even number, I must choose even number from here, right? Correct. So what should it be? 2, 4, 6, 8, and 10, right? Everybody okay? Okay or not? Sometimes I get already 2 marks in the exam. Okay, sometimes, I say all the time. Okay? Alright, now, next, part 2. What did they say? Draw a Venn diagram to represent the sets, universal and B. Draw a rectangle. This is universal. This is B. I'll have 2, 4, 6, 8, 10. And I know what is outside. 1, 3, 5, 7, and 9. So this should be the completed Venn diagram. Part 3. From the Venn diagram, list all the elements of B complement in a set notation. This complement of B complement will be 1, 3, 5, 7, 9. Now, how would I describe B complement in words? Yes, B complement. Okay? What? Okay? Okay, so I can ask a question now. How come I intend to the range? Because the range is already bounded by the universal set. I don't have to put the range. Alright, because our context of discussion is the universal set. Now, if you want to be very, very precise, we can say this. Because you see the text will only write like that. Actually, if you want to be accurate, right, be very, very precise, it's an even number between what? 1 and 10 inclusive. Then if you want to say this very, very precise, what must we say? It's a set of all odd numbers between 1 and 10 inclusive. You have to be very precise. But since our context is bounded by the universal set, I don't think it's necessary. Do you understand what I'm talking about? If they never say anything, then you have to be very precise. Okay? Alright, good. So that is your question number 2. Next one. question number 4. Let us look at question number 4. Can you write down the set first? A is draw a Venn diagram to represent the sets A and B. Now, I want to know which is a subset of which. B is a subset of A. That means B must be inside A, agree? Okay, so this is my A. This is my B. Okay, what do I write inside B? 0, 1, 2, and what should I write at this outer layer? Negative 2 and negative 1, right? Agree? Agree? Okay, good. Now, next part, part 2. Part 2, They ask you to explain. Is B a proper subset of A? I want to know. Yes or no? Yes or no? Yes. B is a as every element of B is an element of A, and number of B, number of A. What did I say must write here? Less than 9. Alright. Okay. Now this is my instructions for now. You finish question 6 on the full step paper. Understand? And the rest of it that I've given you on the notebook, get it done by tomorrow. Is that clear? Then tomorrow I will tell you what is intersection, what is union. Alright? And how do we go about doing it. Everybody clear? Yes or no? Okay. Alright, Stop the video.
That one's
Huh?